Hi ladies and gentlemen, I hope everyone is doing well today. Today we are taking a look at colligative properties. So question one, we have some information on melting ice. It reminds us that we put salt on the roads and walkways to melt ice during the winter so people don't slip and slide. We're trying to think about why do people do this? Why does it melt? Why does the salt melt the ice? You can find the answer to this question within this paragraph. So make sure you read the paragraph, the information on dissociation and total molality of particles, and then go back to question one. It does give you a little bit of a reminder about dissociation. Remember, we were using dissociation in previous chemquests. Remember, whenever ionic compounds are dissolved, they dissociate, so they break up into their ions. So then right here we would see sodium chloride. When it dissociates, it breaks up into Na plus and Cl minus. Same thing down here. Now we're looking at one with a polyatomic ion. So we have calcium nitrate, and it breaks up into its two ions, calcium with a positive 2 charge and nitrate with a minus 2 charge. Remember guys, we do not break polyatomic ions up. And then with this one also is a good example of balancing. So you would see here that there's one calcium on this side, so the coefficient is a 1. On this side we have two nitrates, so the coefficient is a 2. Questions 2 and 3, you're just going to practice dissociating into the two ions. So the first one I highlighted, magnesium chloride, I wrote the formula for you. The second one, ammonium sulfate, again I wrote the formula. So this time you can only practice the dissociation. Remember, when you dissociate, to include the charges and then include coefficients. Remember, we do not add subscripts. Subscripts come from crisscrossing when they bind, so we only ever add coefficients. Next, let me get this one out of the way. Next, question 4. So question 4 is asking us about calcium nitrate. It tells us that calcium nitrate will break up into a calcium ion and two nitrate ions when it's dissolved in water. So I wrote out the formula for you guys. Remember, whenever something dissociates, it's always placed in a solution, it's always dissolved. We normally don't write the water. The reason why we don't write the water is because it's present on both sides. So it's not actually a part of the reaction, it's only what's being dissolved. So I wanted everyone to see that that water really is there, but we don't take the time to write it because it's not affecting the reaction. So we cross them off and we always just write the dissociation like this. So calcium nitrate, remember it breaks up just like we saw in the notes in the previous part to calcium with +2, nitrate, two of them with a -1 charge. So we need to figure out the total number of moles of all the ions in the solution. So remember, when we're calculating total moles, we do not take into account the reactant. We assume that this dissociated and is no longer a part of the reaction, is no longer a part of the product. So when we calculate total moles, we simply just have to add the coefficients. So you would see here calcium has a 1. Whenever nothing's there, it's a 1. Nitrate has a 2, so 1 plus 2 is, well, it's a terrible 3, but it's a 3. So next, question 5. Question 5 is a solution is made out of calcium nitrate, so we already have the dissociation. It tells us that the total concentration is 7.5 molar. It also tells us that we have 2.5 molar of calcium nitrate. So we can put a 2.5 there to help us. Remember guys, this is the part where we assume that the liters are 1. Remember, we assume that the liters are 1 because if we plug that into our molarity formula, we would plug in a 1 for liters, which would tell us that molarity equals moles. Remember, that happens because when you plug 1 in for liters, anything divided by 1 is itself. When we do this, it allows us to simply use the coefficients to change our molarity to calcium ion and nitrate ion. So remember, this is a 1 to 1 ratio, so you can multiply 2.5 times 1 to find that we have 2.5 concentration, 2.5 molar of calcium ion. Then you can do the same thing for nitrate. You would see that it's 1 to 2. You have twice as much nitrate as calcium nitrate. So that means we have to multiply 2.5 by 2. 2.5 times 2 is 5.0. So now we would just need to find the total. We would see that 2.5 plus 5 would give us 7.5. And that's what we see here. We see that it's 7.5. Remember, guys, we do not take into account the calcium nitrate because we assume that it has been completely dissociated, so it's no longer present in the reaction. So we do not have 1 mole of this anymore. Question 6. Question 6 is very, very similar to question 5, except this time we're taking into account molality. I helped you guys out by writing the dissociation, so no one should get this wrong. I did make a mistake, and I made my line a little bit too big, and it got cut off and went on the second one. So you guys can just cross that off and put your line for total molality particles here. And then remember, in this time, instead of assuming liters are 1, we assume kilograms are 1. Because remember, I have the molality formula written right here, moles divided by kilograms. If kilograms is 1, then molality equals moles, and it allows us to use our coefficients just like we did in question 2. And then you just have to add to find the total molality. Question 7, same as 6, just this time you have to calculate the molality. It doesn't give it to us. So remember, I wrote your molality formula here. Molality equals moles over kilograms. Right here, we have grams. So we need to first convert to our moles. So we can convert to moles because remember, moles equals grams divided by the molar mass. So you can find the moles. And then you have 200 grams, so you can convert that to kilograms by dividing by 1,000. Question 8. Question 8, now we're thinking about sugar. So in this case, it tells us sugar is covalent, so we know that it's not ionic. We know from the previous note part that it tells the note section right up here, dissociation, that only ionic compounds dissociate. So this sugar will not dissociate. So if it doesn't dissociate, how much sugar do you think you have in the products too? Will this number change? Now we're coming down to total molality. So we already figured out that adding a solute, adding anything to our solution changes the boiling and freezing points of the solvents. The amount we change depends on how much is added. There are 2 formulas for remembering this. Here's the other page. So the first formula is the delta T, the delta of the boiling point, the change in temperature, will be equal to the molality. So remember, this is total molality. And then Kb is as a constant. It's the freezing point depression for water. Remember, guys, values will be given to you right here. I am just going to write them here so you don't have to keep flipping when you're looking. So then we'll have 0.515, and then same thing right here. This is total molality, and then our freezing point depression, 1.853 degrees C per molality. So that's kind of everything that's talked in here. It just tells you what MT is and tells you what your freezing point depression and boiling point depressions are. So then next, we can look at question 9. So question 9 is asking us about the freezing point. So when we know we're the freezing point, we're using the freezing point formula. So that is right here. Next, it tells us we're using salt water. So we know once salt gets put in water, it will dissociate. It will dissociate into Na+1 and Cl-1. So we know we need to find the total molality, which is Mt. So remember, guys, we can use our coefficients. So if this is a 1-to-1 ratio, then you would have the same amount of sodium ion as you do sodium chloride, which would be 2.5 m. Again, chlorine, -1, is it's a 1-to-1 ratio, so you would find 2.5 m. So then to find the total, remember we don't add sodium chloride because it's already dissociated, so it would be the molality, the total molality would equal 2.5 plus 2.5, which would give us a total molality of 5.0. Remember, this value is given for water, so we have water, so we know that we're going to use the freezing point depression constant right here for water. So now we just have to plug in delta TFP would equal 5, and that would be times 1.853. After you multiply, you should find that it increased 9 0.265 degrees Celsius. So question 10, very similar to question 9. So do all the same steps. Find the total molality by doing the dissociation of calcium chloride. To help you guys out, calcium chloride is CaCl2. So what would that break up into? Question 11. Question 11 is very similar to 9 and 10, but again we're using sugar. Remember guys, sugar will not dissociate in water, so your reactants will look exactly the same as your products. So if you have 2.5 molality of that, then you will have 2.5 molality of sugar at the end. So your total molality for this problem will be 2.5. Make sure you just pick the right equation for freezing point, pick the right freezing point depression, and then solve. Next, we have some information on Raoult's law. Raoult's, can't ever say it correctly, but so here is your formula for Raoult's law. So Raoult's law is the pressure of the solution will equal your mole fraction of the solvent times your pressure of the solvent. So remember guys, your mole fraction from the previous chemquest for a solvent is X of the solvent will equal your moles of the solvent divided by your moles of the solvent plus your moles of the solute. So they gave us a lot of information and they did not give us moles, but we can calculate it because it gave us 21.5 grams of lithium chloride and 84.3 grams of water. Oh no. Alright, sorry about that guys, I should be back now. So I was talking about the mole fraction. We don't know moles, but we can calculate moles because we're given grams of lithium chloride, so you can plug in the grams, find the molar mass to find the moles of the solute. You can do the same thing for water. You can plug the grams into the grams, find the molar mass from the periodic table, and find moles. Then you can plug into your mole fraction formula. Once you solve for the mole fraction, you will then plug that right in over here into Raoult's law, where the X of the solvent is. The pressure was given to you, so then you would just into pressure and solve. That's it for this chemquest, guys. If you have any questions, please make sure you circle them, write down your question, and bring it to class. Hope everyone has a good day.